Now we have seen the properties of the CDF, cumulative distribution function. अभी हम देखने वाले हैं कि properties of probability density function. Probability density function से बहुत ही problem हम solve कर सकते हैं, which are applicable in the electronics, civil and the mechanical engineering. So density function is a very important component. So we have seen the first property is the relationship between the PDF, which is represented by the small x, fx of x is a PDF and capital Fx होता है कि CDF. So always the probability density function is a derivative of the cumulative distribution function. Second important the property है कि always the values of the probability density function is greater than or equal to 0. Always it is never it is negative values. Third important property है, so यहाँ पे dx by k. So the area under the curve for the probability density function is always equal to 1. So this is very important property which is required to solve many problem. That is area under the curve for the probability density function is always equal to 1. Again, like the CDF, sometimes they will ask you to find out the probability between the two variable x1 and the x2. When you want to find out the probability between two variable, you can also solve by using CDF as well as you can solve by using the PDF. PDF से आपको solve करना है, just it is integration area under the curve fx of x dx between the two variable x1 and the x2. And last property है कि if sometimes it will be asked you to find out the probability of the x, that is a random variable greater than the x is equal to 1 minus probability of x less than or equal to x. ये तीन properties है और तीन property के help से कोई भी problem आप solve कर सकते हैं. Now we'll go for the problems on the PDF. Now this is the problem given. So let us look at this for a PDF given by, for the probability density function given by the fx of x is equal to kx between the -1 to 2 or it is 0 else. And they will ask you to find out the values of k or the probability between any two values or the probability of the random variable greater than some value, and they will ask you to find out the CDF, that is a cumulative distribution function. Now let us solve this problem. The first we'll try to find out the value of k. So this is the value of k we'll find out. So for this we have to use the property where the area under the curve of the probability density function is 1. So just we will use that the minus infinity to infinity. So fx of x into dx is equal to 1. This property we have to use. Very simple property. अगर यहाँ पे देखेंगे तो PDF is available only from -1 to 2. तो उसका limit -1 to 2 रहेगा and उसका PDF का value kx है. Just to put the value, substitute the limit for -1 to 2. fx is your the kx into dx. So this is equal to 1. So here it is a k. So integration of the x is your the x square by 2 and the limit of the integration will be from -1 to 2. So this is equal to 1. Here the 2 is constant, k I will take divided by 2. Here the upper limit 2 square is a 4, okay, minus the lower limit is a -1. So -1 square is a 1. So this is equal to 1. So it is equal to the 4 minus 1 3 by 2 into k is equal to 1. So k is equal to 2 by 3. So accordingly you can find out the values of the k. So that is equal to 2 by 3. Now the next is we have to find out the values of the probability between -1 to 1. If you look at from the -1 to 2, the probability density function is a kx. So just we will go to the next slide, -1 to 1, okay. So we will find out the probability of -1 to over the 1. So this is equal to area under the curve from the lower limit to the upper limit. So that is -1 to 1. So fx of x into dx, okay. So this is equal to, we have to find out, that is equal to probability, and we know that the fx is over the kx, k is equal to 2 by 3. So I will substitute. So this is equal to kx, okay, from -1 to 1 into dx, okay. So this is equal to k is equal to 2 by 3. I will take it outside. and integration of x is the x square by 2, and limit will be from -1 to +1. So this is equal to 2 by 3 into 1 by 2. I will take it outside. Upper limit 1 minus lower limit 1 minus 1 is equal to 0. This is the probability from -1 to 1. The next they have asked us to find out the third, that is the probability x is greater than 1. Now let us go for the next slide. So this is the formula to find out the probability for the x greater than or equal to 1. 1 minus 1 to infinity fx of x into dx. And this is equal to 1 minus integration. So up to infinity it is there, but this PDF is available only up to 2. So therefore limit will be from 1 to 2. Fx is k into x into dx. So this is equal to 1 minus k is 2 by 3. I will take it outside. Integration of x is the x square by 2. The limit will be from 1 to 2. So this is equal to 1 minus, it is 2 by 3 into 1 by 2 is a constant. I will take it outside. It is 2 square is a 4 minus 1. So this is equal to 1 minus, it is 2 cancel. 4 minus 1 is 3. 3 by 3 is 1. So this is equal to 0. The next they have asked us to find out the CDF. That is CDF. So we know the relationship between the PDF and the CDF is d by dx of the fx of x. So therefore the CDF fx of x is equal to integration of your fx of the x into dx from this minus infinity to infinity. So therefore the CDF will be given by fx of x is equal to, so if you look at the PDF is only the kx from the -1 to 2. So it's the differentiation of the x with respect to x is 1. So this is equal to the k. So they asked you to find out the CDF, that is cumulative distribution function. We know that the cumulative distribution function is represented by the capital Fx of x, that is equal to minus infinity. You see the lower limit is minus infinity to x. That is whatever the value of x will be there, fx of x into dx. So for x is the less than -1. So the PDF is 0. So therefore the CDF will also be 0. That is the first value we have found. The second they have given the probability density function for the interval -1 to 2. So that is equal to the kx. So therefore the limit for this will be from minus infinity to x. But as this is available from the -1, so the lower limit will become -1 and upper limit will be x as it is. So the kx into dx, and if you solve this, so fx of x for the values -1 to 2, that we will get the 0.33 in bracket x square minus 1. Third, they have asked to find out the probability for the CDF for the x greater than 2. So again, you can take the lower limit. The formula is say minus infinity to x. So therefore, so the different limits for this, the integration will be minus infinity to -1, then -1 to 2. And it is your 2 to x will be there. So if you find out this, so fx of x will come as 1. So accordingly you can write the CDF of this is equal to, that is fx of x is equal to, the first value is 0 for the x less than -1, and for the x greater than -1 and less than or equal to 2. So its value is 0.33 x square minus 1, and another last value that the x is greater than 2, so its value is equal to 1. So this is the CDF. So accordingly, any problem, if they ask you from the probability density function to find out the values of k, or the probability between the two values, or the probability greater than 1, and the cumulative distribution function, like you can solve, and such type of the pattern will be there in the examination. The questions which will be asked on the PDF will be like this. Now the next problem is for the probability density function, which is given by, for x 0 to 1, its value is kx, between 1 to 2 it is kx square, and else it is 0. Again same pattern will be there. Find the values of k, find the probability between the interval 1 to 2, find the probability for the x greater than 1.5, and find the CDF. So as usual, the first property we have to use to find out the values of k, that is the value of k. We can use the area under the curve for the probability density function is 1, that is from minus infinity to infinity. So fx of x into dx is equal to 1, and this is available for the interval 0 to 1 and the 1 to 2. So you have to use from 0 to 1, it is k into x into dx, plus from 1 to 2 it is kx squares, that is from 1 to 2 it is k into x square into dx, and here it is 0, so this is equal to 1. So here k you can take it outside constant, integration of x is x square by 2, so it will be from 0 to 1, plus k I have taken it outside, integration of x square is x cube divided by 3, it will be between 1 to 2, so this is equal to 1. So if you solve this equation, we will get the k is equal to 6 by the 17. So accordingly you can solve, we will get the first value. The second, they have asked us to find out the probability between the variable 1 to 2, that is a interval. So again you can use the property from the x1 to x2 into the probability density function into dx. So this is equal to, so this is equal to, the interval is 1 to 2. Okay, so between the interval 1 to 2, the value is the kx square. So this is the k x square into dx. So this is equal to, k is constant, x cube divided by 3, the limit will be from 1 to 2. So k we know it is a 16 by 17 into 1 by 3, I will take it outside, x cube, 2 cube is a 8 minus 1. So this is equal to 3 to the 6, 2 by 17 into 7. So this is equal to 14 by 17. Now we found between 1 to 2. Now third we will find out the probability greater than 1.5. Okay. Probability of x greater than 1.5. So the formula is simple. Okay. That is from this x lower limit 1.5 to infinity. So fx of x into dx. So this is equal to, if you see, from the 1.5 to infinity. So from 1.5 to infinity. So that is, the limit will be from the 1.5 to 2. That is a kx squares. So 1.5 to 2 into kx square into dx. So this is equal to, k is outside, integration of this is x cube divided by 3, so 1.5 to 2, so k is equal to, you can substitute the values for this, k divided by 3, upper limit divided by 2 raised to 3 is 8 minus lower limit 1.5 cube. So we know the values of the k is equal to 6 by 17 into 1 by 3 into 8 minus 1.5 cube into this, and this value is coming out to be is equal to 0.5441. CDF is given by fx of x is equal to minus infinity, always lower limit is minus infinity, the integration of the PDF. So there are the 4 interval, one is from the x less than 0. So x less than 0, the PDF is 0. So therefore the CDF is also 0 for these values. For the interval between 0 to 1, the PDF is a kx. So this is the fx of x is equal to, from 0 to the x, the lower limit will be 0. This lower limit we have to take 0 to x, and for this 0 to the 1, the PDF is kx. So integration of kx into dx, so k is a constant, that is a 6 by 17. So the x is, the integration of x is x square by 2, limit will be from 0 to x. So if you solve, you will get 3x square by 17. The next interval, there are 4 intervals. So this is the first interval for x less than 0. The second interval is between 0 to 1. Third interval is between 1 to 2. So the lower limit here, the fx of x will be from 0 to 1 and 1 to 2. So this is coming out to be 1 by 17 plus 2x cube by the 17. Third, similarly you find out for the x is greater than 1, there will be 3 integration, the 0 to 1 and the 1 to 2 will be there, and from the 2 to x. So total it is coming out to be this fx of x. Accordingly, we can consolidate. The CDF will be the 0 for x is less than 0. So it will be 2x cube for 17 for the limit 0 to 1. So it will be 1 by 17 plus 2x cube by 17 for the limit between 1 to 2, and this is equal to 1 for the x greater than 2. So such type of the problem will be asked in the examination on the probability density function. Okay, next problem is same type of problem will be asked for the probability density function. The fx of x is equal to k e raised to minus 10x for x is greater than 0, and if x is less than 0, it is 0. The same type of problem will be asked. Find the values of k, find the probability between the interval 1 and 2, find the probability for the x is greater than 3, and find the CDF. For the first problem, you have to use the property that area under the probability density function is 1, that from minus infinity to infinity, fx of x into dx is equal to 1. From this, you can get the values of the k. And the second, for this, you find out the probability between these two intervals, that you can use the x1 and the x2, the fx of x into dx, that will give you these values. And for third problem, you can solve that if it is greater than this, so 1 minus the probability from this fx of x into your dx will be there. Greater than this, you can take from the 0 to 3. And from the CDF, you know the CDF, the fx of x is equal to here minus infinity to x into the fx of x into dx. So you can use this formula and you can solve. I will give its solution at the last.